Or this will be the last fourth example for quadratic. Example 5, we have a wire that is 34 centimeters long. Okay, let me try to sketch it. So let's, I want to do a straight line. Straight line. Okay, so that is, suppose that is 34 centimeters long. And we're cutting it into two pieces. Okay, I'll just say I'll cut it right there. That's the scissor. Cut. Right there. Okay, and each piece is bent and form into the shape of a square. Wow, okay. So let me see. I'm gonna go ahead and like put a red highlight over this first piece. Okay. I want to bring this up a little bit, okay? All right, so say that I have the red piece, which I will bend and make a square. So square number 1 is coming from that piece right there. All right, but I also have the other piece. Square number 2 will come from bending that, I say, slightly smaller looking piece, maybe smaller than that. But you see what's going on here, right? We are cutting a wire and we are making square using both pieces, okay? So in my picture, I was thinking, because unless I have a ruler, I'm probably, one of my pieces will be slightly longer than the other. So this is my imagination. This is how I'm seeing this so far. All right, what do they want? Suppose that the side length in centimeters of one square is x. How about I just make this one x? But if this is a square, all 4 sides are congruent. So all 4 sides are just x's, right? Is there any way for us to write a dimension for this green square? Okay, I need some more clue though. What they told us is the whole thing add up to 34. So I will say this is unknown for me right now. I'll say this is u, the unknown measures. Okay, what I know is if I add up 4 sides of this red square, which is 4x, and the 4 sides of this smaller square for u, what do they add up to be? What was the number that we started with? 34 centimeters, right? So they will add up to 34. I'm gonna solve this for u, okay? Because I don't need an extra variable in my problem. I'm just gonna go ahead and keep it with x's, okay? So if I solve this for u, we'll subtract. Can I change a number, please? Yeah, let me change a number. How about instead of 34 centimeters, how about I say I start with 36 centimeters? I'll change that for my next semester group. All right, why did I do that? Because I was just going to divide everything by 4 and get x plus u equals, what number? 9. I can divide everything by 4, right? I can divide everything by 4 and get x plus u equals 9. If I subtract both sides by x, I can say that u must be equal to 9 minus x. So I know how long that little measure is, okay? This u is 9 minus x. So instead of u, I can change that to 9 minus x all around 9 minus x and 9 minus x. So it was difficult. We know the first one is just simply x, but then the other one we had to do some work to rewrite the side length in terms of x instead of using u. All right, what about them? It says A, find a function that gives the total area, not just the area of the red one, not just the area of the green one, but total, which means both of them together. Okay, so let's find the area of the red one. Area of the red one is x squared, isn't it? Because if you do length times width, that is x times x. And area formula for square is just sides squared, okay? So if I find the area of the second square, that will be 9 minus x squared, okay? Now the red one and the green one are the areas for each squares, but what they want is the total area. So maybe I can drop down some subscripts. Instead of saying A, I could have said A is of 1, area of the first triangle. And instead of just saying A there, I can say A is of 2, meaning that the area of the second triangle. But then the total area function will just be the sum of these two pieces. Do x squared plus 9 minus x squared. That's how you find the total area, right? Area of the first rectangle square, area of the second square, and this looks good. But if I want to use this function, I should probably simplify this. So I'm going to go ahead and FOIL the second side, okay, or this area. If I write it out, that is same as 9 minus x times 9 minus x. Let's go ahead and FOIL this. If I FOIL this, I will get 81 minus 9x, another minus 9x. This will be plus x squared. All right, last step, I just need to simplify this and put it as a, I'll try to write this in a standard form, okay? Notice that I have 1x squared here and another x squared there. They will add up to 2x squared, right? Next, I see there is minus 9x and there's another minus 9x. They will add up to minus 18x. And I just need to write down this constant of what? Plus 81. There was no like term, but yeah, we still have to include it. So that is the total area function, okay? Are we using this? I bet so. Let's see. Find the side length x that minimize, okay, that minimize. And why are they saying that this function has a minimum? Oh, Alexa just spoke. That's freaky. Anyways, okay. So why are they saying this has a minimum? Because this quadratic has a positive leading coefficient, which means this will open upward, okay? If it open upward, if we have the lowest point, so we will have a minimum value. So how do you find minimum or maximum of a quadratic function? You just have to find the vertex. So bring out your vertex formula, x equals negative b over 2a. What is a? A is 2. What is b? B is negative 18. That's freaky how Alexa just speaks in the living room all by itself. Uh-oh. Okay, ignoring that. So if I use the vertex formula, I will get positive 18 divided by 2 times 2, which I will get 18 divided by 4. Oh no, I wanted my numbers to be perfect, but I think it's going to be a decimal. So if I do 18 divided by 4, it comes out to be 4.5. All right, 4.5 centimeters is the side of this square. Okay, that's 4.5. So I like to go back to my geometry. So how about I copy this? And I'll bring this down and label my squares, okay? Hold on. So I just found that this is 4.5. This is 4.5. This is 4.5, and this is 4.5. All right, what about the other square? The other square, I have to do 9 minus 4.5. 9 minus 4.5. What? So guess what we just found out? This square has to be of the same size for us to minimize the total area. Oh, super cool. So, I drew it slightly smaller, but, we just found out that they actually have to be the same size in order for us to say that we minimize the total area. So, okay, I bet they're gonna ask us for the total area now, right? So let's take a look. What is the minimum area enclosed by two squares? we can do this using geometry, right? We can find the area of these squares. So the area of the squares are 4.5 squared plus another 4.5 squared. 4.5 squared plus another 4.5 squared. So I can tell that the minimum area has to be 40.5 square centimeters. The area is 40.5 square centimeters using geometry, right? Because the area is side squared. But what if we use that handy dandy function that we actually wrote? I'll copy this. And I just want to see that we get the same answer when we plug it into the function. So let me find a's of 4.5. 2 times 4.5 squared minus 18 times 4.5 plus 81. I really want to see 40.5 showing up again, right? Because we're trying this two different method, we want to see the same answer. Minus 18 times 4.5 plus 81. Look at that, we also got 40.5. So two different methods that I'm introducing you. Doing it using geometry, like actually drawing shapes and finding the areas, or you can just use the function that you wrote in part A, okay? I think this one was difficult, but you may see this in your Alex homework, so I wanted to just do maybe at least one example of it, okay? Alrighty, that is it for lesson 2.1. Have fun on your Alex homework. Reach out to me if you have any questions on any other topics, okay?